Welcome to BST Lectures. Before moving to our topic, if you are visiting our channel for the first time, please like, share, and comment your opinion on the lecture. And please support us by clicking subscription button and click on bell icon for more updates. And going to the topic, today's topic is probability. We all might hear the word probably, maybe, chances, etc. The whole meaning of these words are the chance of occurrence. Today we are going to learn the basic and the simplest fundamentals of the probability. Coming to the first basic of probability, experiment. In probability theory, an experiment is a series of tests that determine the probability of an event occurring. We are having two types of experiments. One is deterministic experiment and second one is random experiment. Deterministic experiment can be defined in a simple words as, for example, a group of people are doing an experiment. Everyone will get the same result. For suppose if two people are doing 2 plus 2, everyone will get the same experiments result, right? That is equal to 2 plus 2 is equal to 4. In the same ways, deterministic experiment has only one result. And coming to the random experiment in the probability theory says that, for suppose if group of people are doing experiment like tossing a coin, everybody will get heads or tails. We know the outputs, but we don't know what is the exact outcome that can become by the observer or user. That is called random experiment. Event is the common term which we use in the probability. An event is an outcome or set of outcomes resulting from an experiment. It is also known as the subset of sample space. If you want to know what is a sample space, come to the next slide. Sample space. Sample space is a collection or set of possibilities outcomes of a random experiment. For suppose, let us consider an experiment as rolling a six-sided dice. The outcomes of the six-sided dice are 1, 2, 3, 4, 5, and 6. These are the sample space. The sample space is a set of all possible outcomes of an experiment. Mutually exclusive events. These events are the events whose end operation is zero. That is, both the events do not occur at the same time. Here we can say probability of disjoint or mutually exclusive events is zero. And finally, there are three types of definitions of a probability. First one is classical definition of probability. Classical definition of the probability says that the total number of outcomes is defined as n and the favorable outcomes is denoted by m. Here the probability is defined as number of favorable outcomes by total number of outcomes. In the second definition, which is the empirical or one-wise definition of probability, it defines that in the probability it defines also the same favorable outcomes by the total outcomes, but here we are having some conditions. That is, the test must be conducted in the identical conditions and value must be great. For suppose if some test is conducted in non-identical different conditions, then the result might be different. So in this definition of probability, the creator says that the test must done in the identical conditions. And coming to the last type and very important definition of the probability is axiomatic definition of probability. In this, we are having three conditions. First is no negative probability exists. In any probabilities, whether we check tossing a coin, getting the head, the probabilities is 1 by 2. 0.5. It is always greater than or equal to 0. If it is equal to 0, it is called as impossible event and we learn about this in the further videos. Next, total probability. Total probability must be equal to 1. It is known as sure event and probability always lies between 0 and 1. Always the probabilities must lies between 0 and 1. If it is greater than 1 or less than 0, It is not the probability and the sum might be mistake. Thank you for listening, and do like, share and subscribe to our channel, and please support, click the bell icon. Thank you.